でこちらはチール・ジュリアンさんでちょっとロボットのお話ししますが皆さんスネークチャーマーのことを知ってるかな。まあ日本語にならないかもしれない。ヘビ使いのようなロボットチャーマーですよ。彼は実はジュリアンもロボットなんですがこの体の中になんか小さな女性パイロットが入っているのでガンダムみたいにでこれからジュリアン・チール
Hi everyone. That's a bit better. Hi, I'm Julian. I live in Bath in England. Just so you know, Bath is not in London. So this is London, but I live here in Bath. So I work for an amazing open source company called Red Hat. So I'd like to thank them for letting me come here this weekend. At Red Hat, I help make clouds on the internet using Rails and open source. So that's really, really cool. So yay, go open source and clouds. So to start, first of all, I'd like to talk about the past. In 2013 at RubyKaigi, Ron Evans and Adrian Zankic came here to talk to you about a new framework that they've made called R2, which is a way of controlling robots with Ruby. And here's R2. And so I'd like to show you some demos of how R2 has progressed since they came in 2013 to see where it is now. Oh yeah, so this brings us to the present. So here in the present, we now have, we have R2, but as well as Ruby framework to control robotics, we can now also control robots with JavaScript and with Golang. So we'll see a few demos of each of those. So let's get started. Can you read that? Good. Okay, so everybody knows when you start programming, the first thing you do is hello world. So in the world of robotics, the way you do hello world is you blink an LED. So if I show you my camera, excuse me. So connected here, we have an Arduino and an LED, and we're going to run this code on my laptop, and that's going to tell the Arduino to blink this LED, and hopefully we should get it to work. So let's try this. Fingers crossed. Oh no. So I think yes. So every time I connect my Arduino, it tends to change address. So if we just change it to the correct address. Oops. Let's try running this. Yay, it works. So as you can see, we can now do 90% of hardware programming, because if you look around the room, there are LEDs everywhere. I mean, there's some on the Wi-Fi access points and on the exit signs. So we can now program most of the entire world. So pretty much done, I guess. Or we could move further. So the good thing is, once you can control one LED, where's my mouse? We can control multiple LEDs. Does that look right? Looks like some code missing there. So if we go back to here and we run this demo. Oh, I should change the... oh, that's the wrong code, that's why. I can't find my LED, multiple LED, but we can control more than one LED at a time. So a good example of that is if I can maneuver this around my camera here. Okay, camera, can you see? Aha, let's get this to stay. Right, so what I have connected here is called a, what is it called? A DigiSpark, that was it, yes, sorry. It's called a DigiSpark. It's a tiny, tiny microcontroller compatible with an Arduino. And as you can see, it's really, really tiny. You can come and have a look afterwards. It's barely the size of a USB port. So in here we have two LEDs connected. So if I run the code for, oh yeah, that was the code over here. So if we run the code for this, Ruby, what was the file called? Right, Ruby, blink, DigiSpark. Hopefully the red and green LEDs should blink on and off. Yay. Sorry, it's a bit bright. And you're thinking, oh, that's really cool. We can turn two LEDs off, red and green. What use is that? Well, if we connected this to the internet, we could then hook it up to Travis CI so that you can have an LED on your computer that tells you when your tests are failing or passing. So hopefully they shouldn't be going from green to red this often when you're coding. They should just hopefully just stay green. But if I lift this up, see, it's absolutely tiny. It's really, really small. So it's really nice and simple. It's just a few lines of Ruby to control all the LEDs. OK, let's see what's next. Where's my mouse hiding? There we go. Right. OK, so we've controlled, what, one LED, then we've controlled two LEDs. So if you know how to turn one LED on and you know how to use an array in Ruby, we can control hundreds of LEDs. So on here, I have an RGB LED strip, which has got 60 LEDs. Oh, where's my camera? Let's move this. Right. So on here, I've got an RGB LED strip connected to an Arduino with a sound sensor. So what we can do is, the louder the music that's playing, it will light more LEDs up. And it's just using the similar code to turn on not just one LED, but as many as you want. So you could have hundreds of thousands and make a whole video display of LEDs. So if I just unplug this one, and get this one ready. So first of all, we should probably have some music, right, to make sure that this is working. So let's find some good music. You saw it, right? It did. Oh, there we go. Let's clap. Hey! I don't know if you can see. I don't think the music was loud enough. So every time, can you see that? By the way, okay here. I can turn. Obviously, they're not a fan of Lupin the Third, but yes. So we can now make light and sound-activated LEDs, so you can have clapper meters. So that would be great for, very useful for in the lightning talk, so we could see who had the most claps. Anyway, thank you. Right. Oh no, that's not that. Okay. Like this. Right. Let's see what's next. Yes. So the great thing with R2 is it works on a variety of hardware. So it works on a laptop, on an Arduino, on a BeagleBone. Not an Arduino, sorry, on a Raspberry Pi, on a BeagleBone. So you can, and the fact that you can buy all of this hardware incredibly cheap, like a Raspberry Pi is now $5. So you could have an internet-connected device running Ruby, making lights go on and off for like $5. This is really, really cool. Okay, let's see what's next. Right. So, if we... So, I don't know if any of you have ever heard of Apple iBeacons. They are small Bluetooth devices that send out a message that phones can receive, and then you can get... That would then connect to the internet, and you would get a notification. So you walk into a shop, the iBeacon knows you're there, and your phone says, "Hey, would you like some discount?" Well, that's kind of really fun, but it's not the most fun that we can have with beacons. So this is using R2 again with my iBeacon library. So it's just going to scan for iBeacons. So I thought a fun way to scan for iBeacons would be to use a iBeacon-enabled sonic screwdriver. So hopefully this should work. Should be some music. Come on. Nope. Oh. Let's try again. So if I just move my terminal over, you can see that we're getting UUIDs, but I'm not sure why it's not playing the music. But it should be, when I press the sonic screwdriver, it should load up this. So this is iBeacons, and as you can see, it's got a UUID and it's got a signal strength, so you can use it to measure distance. And so this is all written in Ruby, which is really, really cool. All right, let's move this back. Okay. Let's close that. Oops. Excellent, right. So what else have we done? So we've made some music, we've turned on some lights, we've made more music using Bluetooth beacons, or sonic screwdrivers, as I like to call them. So I thought, as we're here in Japan, home of karaoke, there's probably going to be RubyKaigi later. And so I thought, let's see if we can build a karaoke machine using robots. So I have here, this is called a leap motion. It's a infrared device that can detect movement. So if I just plug this in. I shall find the code and then, whoops, where's my mouse hiding? There we go, right. Yes. Right. Ruby Leap music. Okay. Let's put this over. Oops. So, yes. So this is the leap motion. As you can see, it can see my hand here. I was thinking, so karaoke is really, really fun, but we're at a conference with hundreds of people that you might be too scared to do karaoke yourself. To sing yourself. So, using the leap motion, hopefully it should do karaoke for us. Oops, if it works. Again, the demigods are not always in my favor. Let's stop that. Let's try this again. Aha, there you go. Now we can see it. So every time I do a gesture, I think the light in here might be affecting it. But you get the idea. So you can use hand gestures to, instead of having to sing yourself. Right. Okay. Anyway, so this is really, really fun, and you can also use this. So it's got full. It can see two hands, and you can see all of your fingers. So you could even have like musical typing, or you could use it to swipe bugs away on GitHub if you don't want to view them, and it's really, really cool. Sleep motion. Anyway, right, stop that. I feel like I'm rushing far too fast. I'm very, very sorry. Let's get rid of this. Okay, what's next? Yes. So that was us creating music using somebody else's music files. But wouldn't it be really, really cool if we could actually use Ruby to make our own music? Turns out that we can. So, has anybody heard of something called Sonic Pi? Hands up, everyone. Excellent. So Sonic Pi is a way of generating music using Ruby. And what we can also do is control Sonic Pi using Ruby and make our own music. So just rearrange my workstation. Okay, let's load up the camera. Oops, there is no camera. Let's try again. Okay, let's load up the correct camera. Oh, that is correct. Excellent. Okay, right. Sorry. So, here we go. So over here, I have what's called a launch pad, which is a MIDI device. And so if I find the code. Where was the code? CD. Launch. Okay, right. Let's load up the code on here. Launch. Right. So what we're going to do is when we press the keys on the launch pad, it's going to send commands to Sonic Pi. So we're able to physically generate our own music with a little bit of luck. So let's... lost my mouse. Oh, there it is. Right. So Ruby... right. .rb. Okay, is that running? So, fingers crossed, we should be able to make some music. Yay! Of course, now I need to quit Sonic Pi, otherwise it would just keep going. Right, so as you can see, the code is really, really simple to do that. Oh, I've lost my mouse again. Giant screen. Oh, here it is. Right. So all we're doing is as soon as I've pressed a certain key on the keyboard, on my controller, it's just working out the position and then sending either the key of D, F, G, C, or B to Sonic Pi. And so we could like map this whole thing and make a whole orchestra or anything. It's really, really cool and really, really nice and simple. Right. Where did my mouse go? Right. So that's music. That was cool. So, I did mention in the current that we've got, so these have all been Ruby demos, but we can also use Go to control robots. And the great thing is that GoBot is the same kind of framework as R2, so they're very, very, very similar. So, if I load up this file, brain. Oh, did that work? Yeah, wrong. That was a binary. Oh, compiled programs. Aha, here we go. Right. So this is a program written in Go. So if my lovely volunteer would turn on his brain sensor, I shall see if I can connect to it. Aha, okay. So we are now connected to Tenderlove's brain. So if I run /brain and load up my web browser, are you thinking?
No.
Oh, there we go. So with just a few lines of code, we're able to, via Bluetooth, look into the depths of Tenderlove's brain. So I'm not a neuroscientist, but I think this means he loves Japan and RubyKaigi. Think about cats, Aaron. Oh, there we go. So I don't know what we can do with this data. Maybe we could use it to make lights turn on, or maybe we could use it to control Sonic Pi, or maybe we could just make sure that Aaron's still awake during my talk. But it's really, really fun. Anyway, let's see what else we've got. Thank you for your brain, Aaron. I've lost my mouse again. Giant screen. There it is. Okay. What's next? Ah, yes. So, I did mention that there might be some possibly dangerous demos. It's because what I have here is an AR drone, which is an off-the-shelf kids flying robot, which has a wonderful API thanks to the wonderful Jim Wyrick, who wrote the original gem for this. So we're able to control this via Wi-Fi, via Ruby. You'll notice I put it far away from me, close to all of you. Let's see. Let me just borrow this to make sure we've got the... Right. So it's there's the code. It's really, really simple just to get things flying. So if we just... Oh, first of all, I need to connect to the Wi-Fi of my drone. So this drone is called Louise. Thelma, unfortunately, broke, so she's back in the UK. But hopefully Louise will work for us today. Right. Ruby AR drone. Okay, so hopefully this drone should take off, hover a little bit, and then land, and not destroy anybody. Fingers crossed. And then after, as you can see, after 15 seconds, after 20 seconds, it should stop. So round about now. Yes! Yay! So that's kind of fun, but slightly boring, you know. You don't really want to have to just have a few lines of code to make it take off and land again. That's not very exciting. So, oops, let's remove Aaron's brain. Let me just borrow this. So the cool thing is that with just a few more lines of code, hopefully, if this turns on, we can control the drone with a PlayStation 2 controller. If it connects. I always find that Bluetooth is very, very dodgy. It doesn't always work. This doesn't seem to want to be connecting, but that's okay. So we can control it in other ways. But the cool thing is, because it's got the two thumbsticks, it makes controlling it really, really easy, because it's just like playing a video game, but in real life. So you could chase down your friends instead of chasing down Mario, or whatever it is that we do in computer games these days. But that's not working, so let's see what else we've got. Where is my mouse? There it is. Can we make the lights a bit darker so we can see? Anyone? No? Yes, thank you. Right. Cool. So that would have been the PlayStation controller. And so PlayStation controllers are fun to control drones. But do you know what's even more fun? PlayStation 2 dance mats. Okay, so hopefully we should be able to control the drone via the power of dance. Okay, so let's just plug this in, turn this up. We're still connected to the drone. Yes, we are. Okay, let's load up the code. Where did I put it? There it is. Right. Oh, I should find the code for you. So here it is. So this is a gem, again, using R2. So I wrote the Ruby gem for the dance mat. When we step on the buttons, it just goes forward, left, right, kind of normal computer game sort of thing. So let's see if this works. Okay, the code is running. Dance mat's here. So first of all, to start it, I press start. That was fun. Yes, so we can control robots and lights and music with dancing. And as you saw, we also made music. So how about if we combine all of those together? Let me just load this up. So again, we need the camera. Let me just set this up. Right. Okay. Let me just load up the code. Where was it? So many files, and I forget where I put things. Sorry, let's just 1 second. Okay, let's just reset the drone. Okay, so, let's get rid of Sai. Don't need him anymore. Let me just find this code for this demo for you. Launchpad. Oh, where is it? Can't quite find it, but it's similar code. So we've got the launch pad again. So if I load up the camera, Let's see, you see that? So the Launchpad, as I said, is a MIDI device. So it can control things like Ableton Live. So we can make music. And then if we use the power of Ruby to then also control the drone, hopefully we should be able to A, play a live DJ song, 5 minutes, and B, fly a drone. So wish me luck. Let me see, okay. Right, let's try that again without killing anyone. Sorry. Right. Where's the camera gone? Where's my code gone? Okay, let's try that again. Right, anyway, I can't stop the drone. Okay, in my last couple of minutes, let's quickly get to the future. That was it, right. So, future. I think the future of Ruby and robotics is mRuby, because we can run it on all kinds of devices. Like, there was a great talk yesterday about running Ruby on embedded devices, and I really think this is really, really exciting. And a slight side note of what I think the future is, I also think the future of Ruby and robotics is Minecraft. Because as everybody knows, kids love playing Minecraft, and Minecraft on the Pi has an API, which we can control with Ruby. Unfortunately, I couldn't connect my Pi up to the display to show you, but I've got some code which I put on GitHub. I have an accelerometer and a Minecraft pickaxe. So when you combine all of these together, you can actually get 360 rotation and up and down. So you can get kids to write Ruby and control Minecraft with the physical world, which I think is really, really exciting. So the last thing I want to say is everybody knows that Mats is nice, and so we are nice. But what I'm worried about is, what about robot Mats? Will he be nice? So that's why I think we need to control the robots of the future with Ruby, because we already know that we're all nice because Mats is nice. So hopefully the future robots will also be nice. So thank you very much.